Right, so today was one of those extra days where we're going to just do an advanced topic here, just a different topic, not really advanced topic. There was a request to do the JPA, which is a Java Persistence API. Actually, I was looking at the updated versions, and apparently a couple of years ago they renamed it. It's the Jakarta Persistence API now. That went along with a bunch of things where they took a bunch of stuff in Java and they extricated it and made it out into separate projects so that it wouldn't be part of core Java, and then they gave everything else different names. We'll refer back to this here in a second. But otherwise, if you have any questions, we are online, so go ahead and post to Piazza or whatever. Anyway, today is just going to be a pure demonstration kind of example kind of day. You all have now experience writing basic CRUD using JDBC, Java Database Connectivity API. CRUD, remember, is create, retrieve, update, and destroy. And we gave you the API that you had to use to put stuff into your database, to persist stuff into your database. You also had to write code to load stuff from your database. But in actuality, you probably only wrote a very small fraction of what would go into a full system. If you had, say, 6 tables, you have CRUD, create, retrieve, update, and destroy, times 6. That's at least 24 different interactions with your database, if not more, for batch adds and stuff like that. And it can get kind of, not depressing, but it can get, it's kind of like busy work when you're doing so much data access. It's all this CRUD is basically the same thing. You connect to your data, the same 5 steps. You connect to your database, you formulate your queries, you process the results, right? And so what an ORM does, an object relational mapping, like JPA is, you can go ahead and make these connections from your Java objects or your PHP objects or your C# objects or whatever language you have. You can make that connection to the database tables in your database. That's what an ORM is. Every language has something like it. For Java, that's going to be JPA. Right? So it's a framework for managing relational data. Right? It provides an abstract layer between POJOs, plain old Java objects, right? Your Java objects that you've been designing this semester, and the actual database layer under it, right? So it provides this abstraction between Java code and SQL down here, or whatever the database happens to be down here. Now, JDBC does that in a sense, but JPA is written on top of JDBC, providing even more abstraction so that you don't generally have to even write SQL code at all in order to connect to your database and process results. It's an API, so it's an application programmer interface. And it used to be, and the example that we'll see here is going to be in javax.persistence. Remember what persistence is. Persistence is, stick-to-itiveness, tenacity, whatever. It is a saving state to a database. You're persisting that code. You persist that data to your database. And it provides methods for querying and managing data. Since it was renamed to Jakarta, that's why I've got this up, everything is now in the API is still apparently in javax.persistence. I thought it moved according to the Wikipedia article here. Renaming and properties, it's all been moved over to Jakarta.persistence. So instead of javax.persistence, it's now Jakarta persistence. Again, it was just a rename, right? I don't think that there was anything that was actually introduced in 3.0 as far as features go. What I'm going to be doing in our demo today is using JPA 2.0, which is about from 2009. There have been small incremental changes as of 2011, and then again in 2017, adding just small amounts of things to the language, to the API. Mostly, it's been support for modern Java constructs like date-time stuff, streams, and other things like that. It also has Jpql, which is kind of like SQL, but it's an SQL-like query language where you don't query out a table. Instead, you can query Java objects, Java classes, and we'll see that in action here in a second. It's built on top of JDBC, so it's not a replacement for JDBC. It's just an abstract layer on top of JDBC. What it does is it auto-generates basically JDBC code in order to, it writes all the CRUD for you. Now, that does come at a cost, right? Auto-generated code is not necessarily optimized. It's not necessarily well designed, right? It works, right? And so there is a pretty hefty performance hit when you use something like this. And again, the little bit of history here, it's now what? 16 years old at least. 2.0 is 13 years old. And then, of course, the move over to Jakarta is only a couple of years old here, 2019. Okay. It was originally intended to replace what were called heavyweight enterprise Java beans, right? EJB entity beans. In other words, there was something like this that existed before JPA. It's just that it was much, much less wieldy, and so they replaced that with a much better API. Right? Oops. Let's go over here. So to motivate this this demonstration, this tutorial, I've given you the simple database of course enrollments. If you watch the videos, for example, the pre-prepared videos, we go through the design and implementation of this database. It's pretty easy to see. We've got a student table here, a course table, and one student can be in multiple courses, just like you are right now, likely. But also, one course can have multiple students, right? And so there's this join table in between, realizing a many-to-many relationship between those two tables. One student is enrolled in one particular course in a particular semester here, which is just modeled with a varchar 10, right? Spring 2021, or 2022 now, right? Also, we have a student to email table here. One student can have several emails, okay? So that's the setup for our table here. Let's zoom out here. When we have JDBC, we basically need to manage all of our own connections. We need to follow that 5-step process. We need to connect to the database, formulate our query, execute our query, get a result set back, iterate over that result set, pull out each individual value from the table, create our objects, and then then we've got our plain old Java objects, right? So I've got that set up over here for the course enrollment system. Here we've got a course class, right? And it has a primary key here, course ID, a subject, and a number. For example, CSCE, and then 156 would be the number. Right? Those are strings because not all of them are just numbers, but we call them numbers. We've got a student here with a student ID, an NUID, first name and last name, and then they've got this set of strings which represent emails. Okay. So that's only 2 Java classes, right? Versus, where's our database here? 4 tables. Now, if I were doing a full JDBC implementation of this, to do CRUD everywhere would be CRUD times 4 tables, right? And 4 classes or whatever. And so I'd have at least 16 things that I would have to program and maintain and stuff like that. As it is, I only have a small demo here that simply just loads myself up, right? So there's my NUID. That's not my real NUID. But we've got a URL, password, and username here that's stored directly in a Java class. We get our connection, which may or may not throw an SQL exception. We formulate our query here, which is going to select everything from a student. But that's not all, right? We then need to need to process that result, right? We'll go ahead and prepare the statement, set the string, and then later on here, we've got our student and a result set, and we have to check to see if the result set is there, and if so, we pull out the student ID, NUID, first name, and last name, all right? I think I've changed this actually to ID and first, I'm not sure. We'll let this run and see if it screws up or not, right? In any case, then we close all of our result sets, close the prepared statement, close the connection. Actually, we don't close the connection yet. Why? Because we still need to get all those email addresses from the address table, right? And then we need to go to the course table using the enrollment and join to the enrollment table join over to the course table in order to grab all that student's particular courses for that year. And by the end, we've only created one student. All their courses, of course, are there, and all their emails are there. But we took over almost 150 lines of code to just do that one thing. Multiply that by the 16 other things that you have to do, and you can see that we've got a lot of basic CRUD, a lot of boilerplate code that is just write, copy, paste, change, ... Right? I don't know. I don't even know if this will work or not. Let's go ahead and run it. There we go. Oh, it did work. There's John. Okay, it's not me. It's John Student here. John Student with NUID 1, 2, 3, 4, 5, 6, 7, 8 is enrolled in 3 courses this semester, maybe all semesters. I don't know. 156, 155, and 235. Okay. All right. Well, that's JDBC. And it's all something that you're all familiar with already, because you had to write a couple of dozen methods, maybe more helper methods to simplify your job, et cetera, et cetera. And you only did a fraction of what you would do in a real project. What about JPA? How does that save us on some work here? With JPA, what we can do is we can annotate our Java classes to make connections and mappings from the Java class to the table. Alternatively, you can do this in an XML file, but that's a little bit unwieldy, so I'm going to show you how to do it using annotations. The basic CRUD is taken care of for us. All that code that I just showed you is automatically generated by JPA, and it goes out and it generates the code. It makes that connection to the database for us. Right? Instead of maintaining a connection to the database, we have to, what's called an entity manager. JPA defines entities, these things that have some connection to the database, and it manages them all for us, right? If we make changes to this Java object, it handles the updates to the database. If we create a new Java object for a new student or something, and we want that saved to the database, we just tell the entity manager, go ahead and save that to the database. I don't want to have to worry about the JDBC code. I don't want to have to worry about the SQL to formulate that query. I don't want to have to worry about the connection, et cetera, et cetera, et cetera. You handle everything for me. Right? Jpql is standardized and makes queries platform independent so that you are not writing any MySQL code versus Transact SQL code, which would be Microsoft's MS SQL Server, versus something, say, on an IBM Informix system, right? SQL is not, I've shown you only standard SQL this semester. SQL is not necessarily standardized across different vendors. Everything that I've showed you this semester will work pretty much in any SQL implementation, but there's Informix. There is SQL Server, MySQL, Postgres, and a dozen other MySQL implementations that all have their dialects, different dialects with different, same basic language, but a little bit different dialects with different features. Because of course, you want to sell your database, so what do? You tack on features. And then, once you've sold the database, you've locked them in. It's called vendor lock, right? In order to switch over from a SQL Server, you don't want to pay Microsoft anymore. So over to Postgres, that means that you're rewriting everything. Okay, well, it'd be more expensive to do that, so we'll just go ahead and stick with Microsoft. All right. So it leads to vendor lock. But Jpql is standardized, and it doesn't matter what you're running on. It will actually, it'll run on anything. Right? Now we can just use objects instead of worrying about loading and saving them. Right? The clear advantages here is that it's closer to object-oriented programming. You don't really have to worry about the database management at all. As long as you know what the schema is, what your tables look like, right? Then all you have to do is annotate your classes to say that this Java object is associated with this table. This variable in this Java object is associated with this field, this column in that table, etc. Right? It's portable across application servers, persistence products, etc., etc. It can be configured to provide connection pooling, caching, all those bells and whistles that would be bringing in a library or rolling your own or something like that. It can be configured to do all that stuff for you. Right? The disadvantages, it doesn't come without a cost. And we'll see the difference here in a moment. It's going to take like 20 seconds for me to even load something up from the database because it has to generate all that JDBC code, right? It's all done through what's called reflection, okay? It's also a huge resource hog, lots more memory, lots more connections. And it also means that if you're going to use JPA, you need a very, very clean mapping, one-to-one mapping from your Java objects to your database. If you don't have that nice clean mapping where, well, this one kind of maps to this table, but also it also maps to that other table over there, right? It's not a clean one-to-one mapping. You're going to be bending over backwards fighting JPA to get it to work, right? So good design means that you basically need a very, very clean database to object model already. How do we begin? First of all, we need what's called a persistence unit. It's a data source configuration, and you put it all into this persistence XML file. It defines configurations to your database. Instead of storing your password, for example, in Java code, now it is in a configuration file. Now, you could do the same thing with JDBC. You just need to bring in a library or roll some code to do it yourself. But in any case, it all comes free with JPA. Let's take a look at our example here. Right? So I'm going to go ahead and close all of our JDBC stuff here. And over here in a config, I've got a persistence.xml file. There's my persistence unit. I've named my persistence unit cberk database, _database. This is so that you can have multiple persistence units. You might have the same database, but you might have it on a testing server, and on a pre-production server, and on an actual production server, in which case you can keep all three of these persistence units in the same file. Or your application might be connecting to multiple databases all across the world. And for that stuff, we pull from that database. For that stuff over there, we pull from that database over there. By putting it all into one configuration file, all you have to do in your actual code is say, I want to use that persistence unit. Right? It has a bunch of, we're using Hibernate here, which is an implementation of JPA. It's basically the de facto implementation. But we've put all of our configuration stuff in here. For example, our driver. The URL that we're going to connect to, cse.unl.edu/ and then the database that you want to use here. There is the username and the password, right? And a bunch of other things. There are literally hundreds of things that you can put into this file. I've just got the bare minimum to get it to work. Okay. You can control different logging. You can control how it connects to your database. You can control basically anything using this this configuration file, and it'll take care of all that stuff for you. That's our persistence file. Now what we need to do is we need to bring our POJOs, our plain old Java objects, together into a JPA entity. And to do that, we use annotations. This is not object-oriented programming. This is not OOP. This is AOP, aspect-oriented programming. Aspect-oriented programming is a paradigm where you can say that this code should have this aspect or this characteristic. By annotating it or just saying, that should be a JPA entity, right? Or something like that. It is different from object-oriented programming. It is different from imperative programming in that you never actually write any code. Instead, you say, that thing over there should have a logger. And you go ahead and take care of it for me. You being some sort of a framework that automatically generates and injects the code to do it successfully over there. Right? You never actually write any of the code. Somebody else has already done that. You just say that, well, that thing over there should have that piece of code over it, that piece of code. You take care of it. Right? I don't want to have to write that code. Right? JPA entities are expected to be serializable, and also you need a default no argument constructor. You can make it private. Those are just two technical issues. Let's not worry about it. Instead, let's worry about the other annotations. Table maps an object directly to a table. ID identifies your primary key. Generate values. Well, how are you going to generate those primary key values? How did we do it in MySQL or in SQL? Auto generate, right? That looks familiar. Generate type, auto, right? That's what we're going to do. And then you define columns and whether or not they're nullable, right? So let's come back over here and take a look at an example. Now, remember that student object? Where was it? Here's that student object. This is just a POJO. This is a plain old Java object here. Do you see any annotations at all? No. I would have to write my own JDBC code and call all these getters and setters and stuff like that to actually create this thing. Now let's look at the student entity, okay? Now, first of all, entity, that's a terrible name. Don't do that. I just named it for demonstration purposes. Now I've got a bunch of annotations here. An annotation, again, is an aspect-oriented programming concept where I say that this student entity, it should be a JPA entity. And the JPA framework says, great, I'll go ahead and generate a bunch of code and inject it into your class for you automatically at compile time, at runtime, whichever the case may be. Right? It auto-generates all that code for you, so you never have to worry about it and you never have to look at it because it never actually exists, except in a compiled product maybe. All right, my student entity, how does that relate to the database? Well, there's this table called student, and that's the relationship between the student entity and your database. This student table right here. Right? It has to be serializable, and you're required to have a no argument constructor. Those are the two pieces of technical issues that we won't get into now. The ID, right? There's your primary key. How do I know that it's a primary key? I annotate it and say, that one right there, that should be the primary key. These all go above variables, by the way. If I did say private integer foo, right? And I tried to do it twice, I think that it'll compile, it'll run, but at runtime, when it goes to inject the code, it'll say, wait a second, you can't have two primary keys, right? And it'll probably throw an exception of some sort, right? But there's no compile time error because all this stuff is injected at compile time or runtime, whichever the case may be. Right? How are we going to generate these primary key values? We're going to let the database take care of it, and it's going to be auto-generated. Right? Auto increment not null ... Right? How do I say that it's not null? Nullable is equal to false. Right? And which column is it associated with? It's associated with the student ID here. So I've got my database open here. Describe student. There we go. There they are. Student ID, first name, and last name. Okay. Student ID here is the primary key, and that's the table name right there, student, with a capital S. All right, well, what about everything else? What about NUID? All you have to do is map that to the NUID column. What about the first name and last name? Well, you just map those to columns, right? And it takes care of everything for you. Right? Now, there is an issue here with respect to our database in that we've got other tables that are related to this student here. We've got an email table, which is a one-to-many relationship, and we've got a course table over here, which is a many-to-many relationship. How do we handle those things? All right. Well, there are other annotations. Right? One-to-one. I rarely ever use that, if ever, because if you have a one-to-one relationship, why do you have two different tables? Maybe you want to collapse those, right? A many-to-one relationship, a one-to-many relationship, and a many-to-many relationship. Why do we need two annotations for this? Let's go back to the database up here. Now, from the perspective of the student table, what is the relationship to the email table? It's a one-to-many relation, right? That goes in one direction. What about from the perspective of the email table? What's the relationship to the student table? It's a many-to-one relationship. So these bidirectional relationships, it's one-to-many over this way, but it's many-to-one that way. That's why we need two different annotations, right? Because if we're going to annotate one class versus the other, we need to know which way we're going. Right? So for a student to the email table, I would use a one-to-many annotation. And who would have thought? I did. One-to-many for email entities. There's a set of emails entities. All right. Do I have the fetch? Nope. We'll talk about that in a second here. This is going to be a fetch strategy. The idea here is that if you're not going to use the emails, if you're not going to print them out or use them to actually send off an email, why even load them from the database, right? So there are two different strategies that you can use. You can be eager about it, and I don't care if I'm going to use them or not. Load them all up, right, just because I want to have them available. Or you can use, alternatively, a lazy strategy. Right? Lazy loading means don't bother going to the database and wasting time pulling that data if I never use it. The second that I ask for it, though, then you have to go to the database and get it. Right? So there's an eager strategy and a lazy strategy. I think that those are the only two. Yep, lazy and eager. I'll go ahead and change it back to eager here. Eager beaver, go do it whether I ask you to or not. Lazy, only go to the database when I actually ask you to for the data there. Right? But otherwise, how are we joining these things? Well, how did we join these two tables here? There is a foreign key in the email table using the student ID right here. So we use student ID here. I renamed the columns, all right, to be more modern here. Right? This is interesting. I've got a set of email entities and a set of strings. Right? Why? Well, let's take a look at that email entity. Right? So before we do, remember that going from the student to the email table, it was a one-to-many relationship. So in the email entity, what is going to be the opposite relationship? Many to one. And here I've decided to be lazy about it. But I have the same join column here. Why? Because those two tables are joined together using the student ID here. Now, for that, I've had to keep track of the email ID, the address, and the student ID. In other words, I've got duplication in my Java objects now. I've got two entities that are both keeping track of the student ID. Right? One way of avoiding that is by not making this email into an entity and instead using transients here. Right? Transient means that this thing in my Java class, it has nothing to do with anything in the database. Right? Transient is the antonym of persistent. Persistent means saved. Right? Transient means it's not saved. It disappears. It goes away. Right? And so I'm saying that this thing right here has no connection to the database. JPA, ignore it. If I didn't have this here, then JPA would say, okay, emails, that must have some connection to the database. I wonder what it is. I see no annotations. Throw an exception. What am I supposed to do with this thing? By saying that it's at least transient, it's saying ignore this thing. Okay? And then we have the course entity here. The course entity is also annotated, and it's associated with the course table. Well, what's the relationship between the student and the course table? It is a many-to-many relationship. Right? And again, we're fetching all of them eagerly. We're loading up all this data here. But because we've got a bidirectional relationship here now, we need to know how we're joining stuff together. And in this case, we're using a join table. That join table was called Enrollment. And Enrollment has a student ID that goes back to the student table and a course ID that goes over to the course table. And to specify all of that, I simply say join columns. Join column is a student ID. The inverse join column is going to be the course ID. Remember, this is from the perspective of the student table and the student entity. So going one way, we're going to use the student ID. Coming back, we're going to use the course ID. Now you could imagine what would it look like in the course table if I did this in reverse. The course ID would be the join column, and the student ID would be the inverse join column. All right. And that's all for that entity there. Let's take a look at the course entity here. Do I have any connection back to the student at all? This is just a course. It's got a course ID, a subject, and a number. Right? Do you see anything relating to students here at all? Nope. They don't have to be bidirectional. If you only want to annotate your entities to go one way, that's all you need. If you want it to go both ways, then you need to annotate both ways, and you need to provide all that information. This is just if you want to load up a student and then get all their courses. If I wanted to load up a course and get the entire roster for that course, I wouldn't be able to do that here, right, with this design. I would have to go back and I would have to annotate both ways. Another alternative is adding yet a third class here, because remember, in enrollment, it's not a pure join table, is it? We've got a student ID and a course ID, but John's student took 156 in spring of 2022. Where is that stored? Right here in semester. Where is that stored in my Java code? Do you see semester here at all? Nope. Do you see semester here at all? Nope. So what would I need? Yet another class, yet another entity to make that connection. There are other ways of doing it, but I don't want to get that deep into JPA today. Right? Okay. All right. Let's see it in action. The transient defines a non-persistent field. It works through reflection, meaning that it injects code into your database or into your Java code. Hibernate is a particular implementation of JPA. And thankfully now, all those SQL exceptions, which were checked exceptions because they're old, right? Now there are no, everything is a runtime exception now. You don't have to surround everything with a try catch. I still do because it's best practice, but everything is now an unchecked exception, right? They fixed it basically, right, from JDBC. Let's take a look at how we actually load this stuff up. Here's my JPA demo, right? I create an entity manager factory and an entity manager. The entity manager factory is responsible for going to that XML file and pulling up all that configuration stuff. The password, the URL, it's all that other stuff, right? And then the entity manager factory is going to create an entity manager. The entity manager is now responsible for the student entities, the email entities, and the course entities, managing them all. Right? We'll get to this in a second. But here is my first Jpql query. It looks it looks similar but different. Did I say select star from student join blah blah blah, left join blah 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 blah? Nope. I've got a very simple from and student entity. Is that a table in my database? Do you see a student entity table here? Nope. That is a Java object. In fact, I'll prove it to you. Clicking on it takes me to that Java class, right? So what I'm doing is I'm not querying a database anymore. I am querying a Java class, right? And then we're going to all we have to do is get that result list. We do have to typecast it here as a list of student entities. Ignore that for a second. Ignore. Right? Close everything up. And once it's detached, I can go ahead and print everything out. So let's run this. Oh, wow, okay. When I was in my office, it was taking like 20 seconds to get there. There is a performance hit. I didn't think it was 20 seconds bad, and this proves that it's not 20 seconds bad, but it was still a few seconds hit, right? Why? Because it loaded up all the entities, it injected all that JDBC code automatically, and then it went out to the database. But apparently it was way faster here. I don't know why it was way faster. But I've got John Student still from JDBC, that JDBC demo. But also I've got Joe Kerr and Steve Brule here. They're not enrolled in any classes yet, though. All right. So, did I write any SQL CRUD at all? Nope. Let's take a look at what CRUD would look like for C, create. All right. There we go. Let's go ahead and insert Mike Trout. Do I have to formulate a query? Insert into question mark, values, question mark, right? Nope. All I do is create a new Java object, which you do all the time, which you'd have to do anyway if you were writing clear JDBC code, right? Then I say, Entity Manager, you go ahead and persist that student. and then refresh. Okay. Now, I'm going to go ahead and commit this transaction, because if you don't, then the transaction will sit open there. Let me go ahead and run this. That should take a little bit longer. Okay, there we go. And roll this back to rollback. And let me go ahead and get rid of this. And let's run it one more time to see that Mike Trout is now in there. There he is. Did I have to worry about setting all those things, formulating the query, preparing the statement, setting all that stuff? Nope. Right? So it's a real time saver as far as coding goes. You don't have to write basic CRUD anymore. Right? You can also have parameterized alternatives, for example. Right? Go ahead and get rid of this. I want to find a particular student by their ID, 1. Right? I have no idea if that's an actual student. Let's select all the students from student. There we go. Student ID 10 here, so I would need 10. Otherwise, it wouldn't be a get anybody. All right. There we go. And that'll end up being null here, so let's just go ahead and print out. This will probably have a null pointer exception, so let's get rid of this. And let's just go with, oh, I'll just print it up here. Right. No, I don't want this. No, what do I want? Doesn't this return a student entity S? There we go. And let's go ahead and print that out. So we should get back, who were they? John student. S. There we go. Let's run this and see if it works. There we go. There's John student. All right. Were they enrolled in anything? I forget. They had two or three classes, did they? Okay. So that's because down here I'm actually printing out the courses, right? I'm not actually printing them out here as part of the students, but I could, right? If I stole this code here. Let's print out all their courses to show that they were eagerly loaded, right? That they were loaded without me asking for them. All right, there we go. Run this again, and there's all John students' courses. Okay. Go ahead and get rid of that. Get rid of that. Likewise, you can go ahead and create email entities, associate them with the student, right, that you load up, and then persist them, and then you can refresh them. Right? So there are a bunch of functions or methods that you can call. Now, let me go ahead and zoom out there. Where we go? Where's next? There we go. Here we go. Here are the most common ones. Finding, that loads an entity from the database. Persisting, that saves an entity to the database. Detaching removes the connection for the entity manager. In other words, it doesn't change anything in the database. It doesn't change anything in the Java object. It just detaches their connection to the database, so that you can say, all right, well, what if I changed all the data to this? I don't actually want to persist that to the database. I just want to detach it, play around with it, maybe reattach it later on or something like that. Merging, I think that does it. It reloads the entity with values from the, it reloads it from the database, so that if you've got a Java object that you've mutated, that you've changed the first name or something, oops, I didn't mean to do that. I will merge it, I will merge the database data back over into here, right? Flushing syncs up all the data with all managed entity. In other words, it's a save all. There's a remove, which deletes CRUD, right? Create, retrieve, update, destroy. Destroy would be remove. Refresh syncs up the object with the database. I think that means that it goes to the database. I forget. But anyway, if any changes have been made on the database by other code or manually by somebody making changes over here in a different client, then refreshing it would actually refresh everything from the database. You can also query using parameters, right? JPA provides SQL-like query language, again, Jpql. You can still have a native query, so if you want to actually write JDBC code, you can still do it. But it also allows you to refer to objects rather than tables. From student entity, I want to load up SE, where se.nuid is equal to :nuid. We couldn't do this with JDBC. If we wanted a parameter in our SQL syntax, what did we have to do? put in a question mark, and then we had to set that parameter. Right? We still have to set the parameter here, but we can use named parameters. Think back to your project, right? You might have had some debugging issues where, okay, how many parameters are there? 1, 2, 3, 4. What was the order again? You have to look up at your query, right? Okay, the third one was the NUID, right? There's no guesswork here at all because they're named, right? All I have to do is set the parameter named NUID to my NUID, right? And all the question marks go away. Right? Now you have named parameters, which is much, much easier to keep in mind. What did I name the NUID again? Oh yeah, NUID. Why? Because that's its name, right? It's all self-explanatory now with named parameters. Questions so far? Okay, well, we've got enough time here. Do we want to see something from scratch? For example, describe. I've got the video game database over here. Right? I've got the video game database. What we could do is we could annotate at least the game table, right? And load up all the video game database information. So describe, let's select everything from game. Right? There we go. There are 20 results there, GTA 4 through Out of This World. Do we want to see it from scratch? Yes? No? Yeah? Okay. All right, so let's go ahead and create a new package here. unl.cse.games, or video games, whatever. That's where I'll put all my entities. Let's go ahead and go with a new class, game. I'm only going to do one table. I don't want to do the entire database. Right? Well, we might do 2 tables to get the publisher or something like that. So what is in a game? Well, the game ID, which is an integer, right? The name, which is a string, and then the publisher ID. So let's go ahead and take care of those first 2 first. Private integer, right? Game ID, private string name or title or something. Let's name it title because that's what it is. Okay. Let's create a no argument constructor, private game. There we go. I'll just leave it blank here. It doesn't do anything, right? And then we'll create no, I'm just going to load stuff up. So maybe a toString method, public toString, and then we'll print out the name of the game, or string toString. Return this dot game or title, and then in parentheses maybe plus this dot game ID. There we go. Okay. Let me go ahead and create a separate demo class here. New class demo with a main so I can play around with it. All right. Now, this is a POJO. Remember? POJO, a plain old Java object. How do I make annotations to make it associated with this game table over here? Right? What was it called? Game. Well, the first thing I need to do is annotate the entire class and say that this thing is now an entity. Right? I'm going to have to import that from javax.persistence. There we go. And I need to make that connection from the game object to the game table. And that's going to be the table annotation. And name, what was the name of the table? GAME, all lowercase though. Right? And this is why I advocate a modern convention of naming your tables upper camel casing, because ultimately that's what your objects are going to be. And your variables lower camel casing, because ultimately that's what your columns and your variables are going to be. Right? Did I do that over here? Yes, I did. All right, there we go. And I have to bring that in too. Import that. Okay. Now I annotate each one of these things. How did I do it before? Well, this is obviously the primary key, so ID, right? And it's going to be a column. The name of the column that it's associated with is game ID, right? Game ID. And we also need an auto-generated strategy here. I'll just go ahead and steal this code right here because I don't want to type it out. There we go. Order doesn't matter generally. Let's go ahead and import this. Come on, and import column. There we go. Okay. There. There are no semicolons in your annotations. Sorry. Okay. By the way, where have we seen annotations before? You remember override? And I told you, don't worry about it, right? What is this doing? It's saying that this has been overridden from the superclass. It's an aspect, right? If you put that same thing anywhere else, it'll say, wait a second, game is, that's not a function, that's not a method in the superclass. There's something wrong here, right? It's basically a sanity check to see, am I overriding a method or not, right? It's an aspect. This thing is an overridden method. This thing is an entity, right? It's a completely different programming language paradigm, aspect-oriented programming. Now what about title? That's going to have a column, associated what? The name, or name is going to be equal to, was it title? What was the name of the column in the database? Name. They don't have to match. It's very nice when they match because then you can just cut, paste, cut, paste, cut, paste. But if you've got something that's named differently, then you can accommodate that here. Right? Title makes way more sense. So you can fix the mistakes of the database designers, right? Okay, there we go. I'm going to steal a bunch more code over here because I want my entity manager factory. I want my persistence. I want my persistence unit right here. It's the same database, by the way. And we'll begin our transaction. There we go. And then we will formulate our query string. Query is equal to, but instead of selecting, you know, I could say select everything from game and then go ahead and execute that query. That's SQL code though, right? I don't have to do that anymore. Right? I can say from, and now it's not game, instead it is game, capital G. And it recognizes that that in fact is a Java class now that I can click on. Okay. All right. Let's see. I don't want to have that try. I'll just have one big try catch. How about that for simplicity? There we go. All right. Error loading. ... Error loading. There we go. All I'm doing is throwing it back. Okay. Now we need to execute this query. So how do we do that? Similar to what we did here. Right? I need to ask the entity manager, please create this query and give me the result set, or the result list, excuse me. And I can do that. And then have I ever showed you the var keyword in Java? Var foo is equal to. Aha, okay. I wonder what properties this is. Compiler. Okay, we're still on Java 6 here. This was introduced in, I believe, Java 12 or 13 or something. Don't use it. We'll forget about that for now. Basically, if you want to know what it is, int foo is equal to 42, right? Now, that's pretty clear what foo is. It's an integer. They added a var keyword, var short for variable keyword in later Java. And I don't know what variable type it is. It depends on what I assign it. Var will then become int. But if you change it to 42, right, then it'll magically become a string, right? It's really, really stupid feature in my opinion, and for not much savings. So don't worry about it. But this returns a list of, what, games, right? Games. There we go. And it's going to complain about this because I'm not typecasting it, but that's okay. And then we'll go ahead and just print them all. Right? So for game G in games, we'll go ahead and system.out.println G. There we go. Close. We have to close everything up too, right? Oh, yeah, this finally. That'll do it. Did I already do that, though? Nope, finally. Okay. We're going to close the entity manager, and then we're going to close the entity manager factory as long as they're not null and as long as they're still open. Just like we close connections, close result sets, and close prepared statements. We still have to close that stuff. All right, well, if it was successful, we should get that list of 20 games at least, right? All we're going to get is the game ID and the name, though, because we have not created a publisher table, a publisher object, and annotated that. So let's go ahead and see if it works. I'm hoping it does. Hey, cool. All right. So 0 to 60 with almost no CRUD written at all. Right? All I had to do was create the class, which I have to do anyway, right? And then annotate it, which I can do while I go along. Right? And there is my loading up of that entity from the database. We still have enough time. Do we want to do the publisher? Okay. We've come this far. New class publisher. What is a publisher again? It's just an ID and a name. So public, or not public, private, integer, publisher ID, private, string, name. There we go. And let's do a toString method here too. Public string, toString, return this dot name. I won't worry about that ID. Okay. Now a lot of it is just cut and paste, right? Over here in the publisher, it's not the game table anymore, it's the publisher table. Over here in the game, I'm going to go ahead and grab all that stuff too and change it to publisher ID and steal this column name associated with that publisher there. Right? Now I do have to come back to the game table here and add in a publisher. But instead of adding in a publisher ID, I use composition. Private publisher P. Right? And I need to make a connection from that table to the other table. Right? So this is going to be, darn it, now I forget the syntax. Let's go ahead and look back at our notes here. It's going to be a one-to-many relationship. Here, it's over here. One publisher to many games. So from the game table, it'll be many to one, right? So at many to one, right? And we'll have to import that. And for that, I'm going to have to look at the email table here. Many to one, fetch type, student ID. We're going to steal that code there. Game table, here we go. All right. Many to one, we can't have both of them. So there we go. And not student ID, but publisher ID. There we go. I'm not storing publisher ID anywhere inside this table or inside this object. Instead, that's being stored in the publisher object right there. Right. Now let's modify it to make sure that we're actually pulling this stuff by, and then plus this dot publisher. P. There we go. Terrible variable name, but it's quick and dirty to get the job done here. Right. And now we should have all those publishers as well. By Rockstar Games. Not a single join query at all. Right? All I had to do was write a join column. Where is it? There we go. Join column right here. Right. Annotate it. You take care of those details for me. I don't want to have to worry about this crap. Right. You can go from 0 to 60 a lot quicker, right? By not having to write all this code. By X-Wing versus TIE Fighter, by LucasArts, et cetera, et cetera, et cetera. Right. So you could pretty much have an entire CRUD application up and running as fast as you can write your actual POJOs, plain old Java objects. Right? One question, though, is what happens when you don't have a clean relational modeling, or relational mapping, excuse me. Right? For example, inheritance. You had to deal with this in your project because you had many different types of assets. The strategy that we highly suggested everybody take was a single table inheritance strategy, right? Why? Because it's the easiest. It's the cleanest. If you want to, you could go with a join strategy, where additional state is provided in subclasses, and that's provided in separate tables. So you would, for example, your project would have an asset table, and then a crypto table, and a stock table. And then under that, you'd have yet another option table, a put table. And then under that, you'd have a put table and a call table, right? Whatever you needed, anytime you needed brand new state in a subclass, you would create a brand new table, right? Or a table per class strategy where one class is defined for each table in the hierarchy. I guess that was what I was describing there. One table for every class in the entire hierarchy. A joined would be just the stubs all the way at the bottom. You wouldn't have an asset table. You would have a crypto table and a stock table and a property table, but you wouldn't have that intermediate table. You would just have repeated data in different tables, right? But again, what did we suggest to everybody? A single table inheritance strategy. JPA supports any of these, right? Let's take a look at what it would look like, though. Let's go ahead and close all this stuff. There we go. I've got an employee demo here. I've got an abstract class that represents an employee, right? And then I've got two subclasses. One of them is an hourly employee, and one of them is a salaried employee, okay? This table is called employee, right? But there is no hourly employee table. There is no salaried employee table. Instead, the inheritance strategy here is a single table. So here's one record, here's another record. How do we distinguish between whether or not this record is a salaried employee or an hourly employee? The exact strategy that we suggested to you, you use a discriminator column. In this case, employee type. You probably did asset type, which would have been what? S, P, or C, right? And then for an option, it would be SP for put, SC for call. Is that right? Something like OP and OS, OC, something like that. Who cares, right? But how would you actually do this in JPA? Well, all you need to do is say, what is your discriminator column value in the subclass, right? This entity is called an hourly employee, right? But it is not tied to any specific table. Do you see a table annotation here? Nope, because there ain't no table named hourly employee. Right? Instead, there is just one table named employee, and there's a different entity that is a subclass of that entity that is distinguished by H or S, depending on what type it is. Right? And let's see, let's load this up. Yeah, nope, I wanted employee demo. There we go. Right? And I've got log for J here as well. Right? There, George Bailey getting base pay, total pay, et cetera, et cetera. There's Henry Potter and Mary Hatch and Billy Bailey. So I must have written this at Christmas time or something. Those names ring a bell? Oh, no? It's a Wonderful Life? You watch that every Christmas, don't you? Just like Christmas Story. You watch that every Christmas, right? And so there's George Bailey and the evil Potter, Mr. Potter. There's his Mary, I don't know who that is, but there's his brother, Bill, or uncle, Billy Bailey, etc. Right? And they were all employees of this fake company that I made, right? All right. No difference at all here. Instead, all of the logic is taken care of automatically by JPA. It sees this discriminator column and says, oh, that's an hourly employee. So I will create an instance of an hourly employee with everything set for you. Right? Awesome. So it does take care of inheritance. Right? There's some older resources but that I wouldn't recommend. If you were to pick up JPA, start with JPA 3.0. Right? I would not, you can refer to this stuff, but getting it set up, I would also recommend doing it automatically using Maven or something like that. Just the biggest hurdle to this stuff is to just get a Hello World program working, right? Just get that that game table to load, and if you can get one thing to load, then all the other pieces fall into place. But it's that initial setting up your configuration, setting up your project to use JPA that's literally the hardest part. Everything else is super easy, right? As long as you've got a good mapping, right? If you don't have a nice one-to-one mapping between your entities and your Java, between your tables and your Java objects, it's going to go all haywire. You're going to be bending over backwards, fighting the framework, and at that point, what you'll end up doing is you'll end up going back to the native queries. Where is it? Nope. You'll end up doing a native query and then doing all the manual CRUD to begin with. Where is it? There we go. Native query. You'll go back to JDBC and you'll write JDBC code because there's this one-off entity that spans 5 different tables, and it doesn't have a nice clean mapping. So let's just write all right, fine, write the damn query and get it done, right? But as long as everything is clean, it is super easy to use JPA. And I will say that every language has something like this. ORMs are not something special to Java. If you are working in C#, I think they call them ADOs. No, DAOs. Data object, abstract, ADOs, abstract data objects. Other languages have frameworks, or at the very least libraries that you can bring in so that you never have to write any SQL code at all. All you have to do is set up some sort of a mapping between your tables and your objects or your classes or whatever, and it does all that stuff for you. Right? So now that you've gone through JDBC, seen how much boilerplate you have to write to do basic CRUD, right, and realize that the back-breaking work that it is typing, right? It's much better than digging, right? But once you've gone through that and understand how it works, okay, now you can use an abstract layer on top of that JPA so that you don't have to do so much back-breaking typing work. Right? Questions? Then when we come back on Thursday, we'll just have a course wrap-up, retrospective of what we've done, where we've been, and where you can go from here. Otherwise, make sure that you're filling out that course evaluation. Like I said, only about 15 out of 116 or so have filled it out. I'd like to see at least 50% response rate, if not more. But please go ahead and make sure that you're telling your colleagues to fill that out as well if you haven't. Right? It's on Canvas, as usual. All right, I'll see you on Thursday then.